Hi everyone. So I said I'd make a quick video on our analogy for electric current. So in my analogy, we've got a bottle of water, okay? And if you can imagine that the little particles or the little molecules of water that are sitting around inside the bottle, these ones are like the electric charge, okay? So if you flick back up along the slides, you'll see we have positive charges and we have negative charges. We're talking about the negative charges because these are the ones that flow in electric current. Electric current being based on the electron, okay? So the name itself should tell you that it's the electron, not the proton, okay? So here's our little pieces of charge. Doesn't really matter if you think about it as what way exactly you think about it, but here's our little pieces of charge, and we're going to make them flow, okay? And they flow from one place to another, and of course the flow rate is our current. And that wasn't a very big flow rate. I can make the current really small, or I can increase that current way more, okay? And that's my really short, useful analogy, I think, for electric current and electric charge. So if you follow that up, we would say that I, which is the current, is going to be equal to the electric charge divided by the change in time. And in symbols, that is I for current, because I is obviously for current. Q is the symbol we would use for electric charge, and time, or it would be just represented with T, or sometimes delta T for the change in time. Okay, and so this basically tells us that current is measured in, because if we plug in the units of Q, well, Q is a charge, and charge is measured in coulombs, and time, of course, is measured in seconds. If you look at the units, which means that current will have the unit of coulomb per second, or coulomb over second, also known as coulomb seconds to the -1 is another way of writing it, but it's more commonly known by its stage name, the amp. Okay? Uppercase A stands for the ampere, which, as you can imagine by the little accent that's on top of the E there, was named after a French guy. So, hence, the unit of electric current is measured in amps. Okay? Uppercase A, or if you're writing the word, you would use the lowercase version of the word because the guy's name was Ampere. So we try not to use the uppercase. Uppercase refers to his actual name, lowercase referring to the unit, amps or ampere. Another way of saying it. Okay? But uppercase A is the symbol for electric current. And of course, current is a flow rate. And that is the key point. It is a flow rate. Okay? And that is electric current for you. So just to take a quick example, just run through the very simple example that we had from one of the classes. So if we've got a charge of 5 coulombs and we've got a time of 10 seconds, then we want to figure out, well, what is the electric current the electric current I, apologies. So I'll make my list. That's step number 1. Step number 2, I write my equation, and of course we can use our equation from our formula. We've got Q on top equal to I times T, so we've got the quick triangle. We're looking for current, so you cover what you want, and that leaves us with the charge divided by the time. Okay, so the electric charge divided by the time, 5 coulombs of charge divided by 10 seconds, which would give us 0.5 coulombs per second, or in correct notation, it would be 0.5 amps, uppercase A for amps. Okay, so hopefully that makes sense to you. You should practice rearranging this triangle in terms of all of the variables using the triangle method. So you've got Q is equal to I times T. Just by covering the Q, I, of course, which we've just used, cover what you want, and you're left with the charge divided by the time. And lastly, if you're looking for the time, then it would be the charge divided by the current. Charge Q divided by the current I, and that will give us the time. So there we go. 3 formulas, as usual, wrapped up in one beautiful, concise, small triangle. Okay? Hopefully that makes a bit of sense to you. That's my analogy and how to use it. I would like you to think of your own analogy. Okay? I would like you to think of your own analogy that doesn't have to be perfect, by the way. Your analogy doesn't have to be perfect, and that's a key point when it comes to analogies, is that eventually all analogies break down, and they're never perfect. Okay? And water, the analogy of water will get so far, and then eventually it'll break down, and we'll just have to switch analogies. Okay? We'll have to think about it in a slightly different way. So I'd like you to come up with your own analogy. All you need is something to move in or to flow in some kind of a way. One thing is going to be your current, another thing is going to be your charge, and your time, well, that's still going to be time. Okay? So please add a page to your OneNote that explains your own analogy for electric current.